Okay, so here's a few problems off of page 545. I thought I'd work some of them out. The first thing, if you have x and y on the same side, especially when you're trying to graph, is to get the y alone. So I minus the 2x minus the 2x. So 5y is greater than negative 2x plus 5. Divide it by 5. And y is greater than negative 2/5 x plus 1. I don't flip the inequality even though there's a negative right here because I am not dividing by a negative 5. Now, if that would have been a negative 5 right here, so if all these would have been negative, I would have flipped the inequality. But since it was a positive, I do not flip the inequality. So the only time you do flip that inequality is when you multiply or divide everything by a negative. So just a quick thought. All right, so this says I start at 1. I go down 2 and over 5. And then you just connect your line. And there you are. So that's the first part, but then it says it's greater than, means that I'm going to shade above. Okay, so greater than, I shade above. And that's the answer for that. Again, you could go to your calculator. You go to y equals. You move your cursor all the way to the left. When you do this, the whole thing's going to be highlighted. And when you hit enter, you're going to go down to the middle one. You're going to have 3, unlike mine. You'll have 3, and you go to that middle one, and you can change the inequality so that you can make it a less than or greater than whatever you need to. So anyways, just another option for you to use your calculator on that. Now the next one. This has y's and x's everywhere. So what we're going to do is simplify it. So we're going to distribute the 2 in. So I have 2x plus 2y. I still have that 3 greater than y plus 3. So I'm going to minus the y over to here. I'm going to minus this 3. So that's gone. And then I minus 3 over here. Well, that goes away as well. And then I minus the 2x from each side. So that's gone. 2 minus 1 is 1. That's gone, that's gone, negative 2x. So that means I'm starting at 0. I go down 2 over 1, down 2 over 1. Okay, and now, oh, I messed up on this first problem. That should be a dotted line. So this should be a dotted line, so make sure I do that dotted. So it's a dotted line. It's greater than. The y values are bigger up here than they are down here. So I shade where the y values are bigger. And that's my answer on that one. So 21, that's going to be a less than. Since it's just plain old x, I can come over here to x. And remember that if it's an x, it's a vertical line. And then numbers less than 6, well, 5's less than 6, so that means I shade to the left side. Now I come over to y is less than or equal to 5, so that is a solid line. So I come up here to 5, and I shade below, because 4 is less than 5, but 6 is not less than 5. So I shade everything below, and that's that answer. 29. If you remember, this is a parabola with a vertex opposite of that, so it's at 2, 1. So 2, 1 is my parabola. There's not a number in front of here, so for the first one, I'm going to go over 1, up 1. The next one, I'm going to go over 2, and if I square 2, I'm going to go up 4. So I go over 2, up 4. 2, 3, 4. The next one I'd go over 3 and up 9. 5, 6, 7, 8, 9. It's a solid line. Okay. Again, you could go to your calculator. I don't have the buttons to do the inequalities. I need to download a pack for it on my computer, and I haven't yet. So anyways, you can graph it on your calculator. You put in the inequality, it'll shade for you. If you need to see those points better, you hit second graph. And you move it back to where it needs to be so that you can see it. Eventually it'll get there. And it'll probably fly on by. So anyways, there's my vertex going by. Hey, that was a good stop. So 1, 2, 0, 5, 4, 5, 3, 2. So anyways, you can see we have that. And then since it's a less than, well, these y's inside of here are smaller. So I go right up the vertex, okay? So these y's are smaller than these ones. So these are the ones that are going to work, is everything on the outside of it versus on the inside. Okay, and a quick way to do that, pick any point. So if I pick like 2, 2. So x is 2, y is 2. 2, 2. 2 minus 2 is 0. And 0 squared is still 0 plus 1 is 1. Is 2 smaller than 1? No, 2 is not smaller than 1. So this point inside did not work. So that means everything on the inside would not work. So I would shade where the opposite place, which is on the outside. All right, this one, if you remember, that's a circle because they're both squared and it's a plus between them. And they don't have fractions and it's not equal to 1 or greater than. So I know that this is a circle with the square root of 16 being my radius. There's no numbers next to this. You know, when we have it like this is like the center that's moving. When we have it x plus h, y plus k, that moves the center. So there's nothing moving the center, so it's at 0. That's my center. So then I go 4 in each direction. It's a solid line. And you're going to make a beautiful looking circle. Whoa. Okay. Something like that. And since it says greater than, it's on the outside. Less than is on the inside of a circle. And we can hurry and plug a point in. I can pick 0, 0. 0, 0 squared is still 0. Is 0 bigger than 16? Nope. So the inside didn't work, so that means we shade on the outside. All right, the absolute value of x is less than or equal to 3. Okay, you can go to your calculator if you want and just see what x, the absolute value of x. Well, no, you can't do that because you can't do the absolute value of x. So if you want to go to Desmos, you can try Desmos. The beautiful free graphing. And you can type in the absolute value of x is less than or equal to 3. Now, normally absolute values make a V, but just think about it. There's no y is equal to x. It's just saying the absolute value of x is less than 3. So think about it. What values can I plug in here for the absolute or for x, that when I take the absolute value, it would be smaller than or equal to 3. I can't plug in negative 4 because 4 is not smaller than 3. But everything between negative 3 and 3, when I plug these values in, will work. And it doesn't matter whether they're up here or down here. The x value is going to be between negative 3 and 3. Anyways, I wanted to hurry and show you Desmos because you can't use it on your test. But some of you like to double check your work, and you know there's nothing wrong with checking your work as long as you're learning from it, because that's the idea, is that you learn. So sometimes it helps to get a good visual of what you're actually looking at. With the same idea, I think the next problem you have is 32. It's a y, absolute value of y is less than or equal to something. It's just going to be straight lines that go this way, okay? And then you'll have to decide which ones it should be between the lines or outside the lines. So anyways, on 35, y is greater than or equal to the square root of x. If I plug in 0, the square root of 0 is 0. If I plug in 1, the square root of 1 is 1. If I plug in 4 for x, the square root of 4 is 2, so that means y equals 2. If I plug 9 in for x, so I'm plugging 9 in for this x right here, the square root of 9 is 3, so that means y would be equal to 3. So solid line again. Connect those dots. You're supposed to connect those dots. There, now they're connected. Not prettier, but they're connected. So now y is greater than this. Well, does that mean I should shade above or below this? Over here, there's nothing, because you can't have the square root of a negative number for real solutions. So there's nothing over here. So I'm just going to pick some number. Let's pick this number right here. X is 9, y is 1. So is 1 greater than the square root of 9? Is 1 bigger than 3? Last I checked, 1 is not bigger than 3, so this point did not work, so that means under here isn't where I shade. Instead, I shade out here, because this is going to be the region where the y value is bigger than the square root of x value, okay? So I could try that and make sure it really does work. I could pick a point right here. So like 3 is plugged in for y. The square root of 4 is 2, so is 3 bigger than 2? Yep, so that worked out here. So every point that's shaded, or every place where it's shaded, if I pick a point, will make this equation true. All right, this next one, we have two equations. We need to solve for y on each of these, so I'm going to minus the 2x over here. So those are gone, and then I'm going to divide everything by 5. So I now have y is less than negative 2/5 x plus 1, because 5 divided by 5 is 1. I'm going to do the same thing. I'm going to add the 3x over here. So I now have 4y is greater than 3x plus 4. Divide it all by 4. Y is greater than 3/4 x plus 1. Okay, so I now have my two equations. I come right here at 1. I go, and they're both going to be solid lines. Up 1, 2, 3, over 1, 2, 3, 4. Up 3, over 1, 2, 3, 4. So I can do the same pattern. Up 3 over 4, or down 3, left 4. So now I can connect those dots. And it's going to be shaded y is less than or greater than this one. So everything that's up here. And now I do this one. I start at 1. I go down 2 over 5. Down 2 over 5. Or I could do backwards, up to left 5. Up to left 5. Connect my dots. Now on this one it says to shade less than that. That's supposed to be below that line, not highlighting the line. So everything less than or equal to that, that's down here. So the only place where they intersect is right here. So my actual solution is just this part, because this is where it works for both equations. Okay, so any point in here will work for both equations. Now the next one. So it says x squared plus y squared. Hopefully that triggers in your brain, oh yeah, this is a circle. Okay, it's a squared and a squared. There's no fractions, so it's not an ellipse. Square root of 100 is 10. So I start at 0, I go up 10, right 10, left 10, left 10. Make a big circle. Probably as painful for you to watch me try to draw a circle as it is for me to try to draw it. All right, there's a circle, kind of. And it's supposed to be dotted. All right. Come on. Can't even cheat. Won't let me choose the tool with that recording thing. So here it is. Here's my dotted circle. Maybe the dotted circle is better than the other one. It has moments. Now it says less than is shaded on the inside. Okay. So less than is shaded on the inside. So there we go. There's the shade on the left, on the inside. My line's dotted because it's a less than. So there's my circle. Now it says y is greater than x. Well, that means we start at 0, we go up 1 over 1, up 1 over 1, up 1 over 1. And it's greater than or equal to, so that's just going to be a solid line. Oops, that's supposed to be a white circle, or a white line. Oh, somewhere I got off on my circle, or on my line. My computer's being way slow in responding to me. There we go. Oh. Faster to draw a new one. All right, that's where it was supposed to belong. I'm just going to delete that one. Maybe. Like I said, my computer's going super duper slow. Not a good thing. All right, leave it alone. Hopefully it stays there. So now it says to shade y is greater than, so that means I should shade above this line. So that's me shading above the line. So everything above the line, inside and outside the circle. So far the only place where they intersect is in here. And now y is greater than or equal to 1. That's going to be a solid line that goes right through 1. And it's going to be shaded above that. So the only, whoa, too far. So now the only place that it's actually shaded by all three of them, so realize that's shaded above the line. So the only place where all three of them are shaded is inside this circle, above that line, and above that line. So this is the only part that is your actual solution, is where they all intersect. So anyways, that's the actual solution on that. And that's all the problems that I have written down. So leave it on a, there we go. That's a better picture now. But anyways, that should help you do those with that assignment. Give you a good chunk of problems to look at. So good luck with that.